The second component of the section properties of rational exponents is to deal with radicals and how we can operate with them. So we talked a little bit before about how to simplify radicals in a simple sense and how to simplify even things in the fourth root, fifth root, but how can we maybe combine radicals together or simplify them in general, like in terms of, okay, what if I give you the cube root of 54? Can that even be simplified? Well, actually that one can. So we talk about how that process goes about being done and then how the values can be put in simplest form. So the first thing we're going to look at is how to write radicals in simplest form. So this video, actually, you're going to notice there's only going to be 2 of these 4. We're actually going to do the other 2 in class tomorrow because I think they're very important, and I think we have a little bit of time to complete them. So the quiz will be a little later than usual, but nonetheless, so this is only going to be bullets 1 and 2. The second one, combine like radicals, that's when we add and subtract them. That one's relatively complicated in the sense of how to simplify them and then combine like terms. Combining like terms is a lot like how you combine like terms with variables. Then the other 2 we're going to look at, just get them up there quickly, is simplifying radicals involving variables, adding and subtracting radicals involving variables. It's not very difficult. I just like to be there to explain a little bit more in detail for you. Okay, so writing radicals in simplest form, those arrows are simply there to help us out when the time comes. For the first example, we're going to talk about how do I simplify the fourth root of 64. Well, I guess you could probably at this point assume that the fourth root of 64 doesn't come out to the simple answer in terms of an integer, for that matter, a positive integer. So if we're looking at it, okay, so we have to ask ourselves, what fourth root goes into 64? Just like you would ask yourself the same question dealing with like the square root of 4 goes into square root. You have to ask yourself the same question. In this case, it's going to be the fourth root of 16. Well, the fourth root of 16 is going to be 2, right? So 2 times 2 times 2 times 2 is going to be the what ends up being 16. So the fourth root of 16 is going to be 2. And we keep 4 square roots of 4 the same because this right here is a value. We know if we put it in the calculator, it's going to come out to something. We just have no clue what. So we're not going to bother trying to figure that out. We'll just write it again in simplest form saying 2 fourth roots of 4 is the final answer. So it's a little harder to say, but you say it like you would say 2 square roots of 4. Now it's 2 fourth roots of 4. It's a little trickier. Then if we look at example 2, we have the cube root of 8 over 7. Now this one's very challenging. I picked the very difficult one. The quiz is going to have something that's much simpler, but I just wanted to give you something that's a little tougher to look at first time. So what we want to look at is, okay, we have the cube root of 8 over the cube root of 7. We know that's the case because the property, the quotient property of radicals, we're able to divide that up into 2 separate radicals, one in the numerator, one in the denominator. We know the cube root of 8 is going to end up being 2. So we're left with 2 cube roots of 7. This looks like, I'm just going to box this in. This looks like a beautiful answer, but unfortunately, it's not because you can't have a radical. This is where it's going to get tricky. Before, if this was the square root of 7, we would multiply by the square root of 7 to ensure that, the denominator is now going to be a whole number, which is 7. But because it's a cube root, we're going to multiply by something, so it ends up being the cube root of a value equal to 7. So in this case, we're actually going to multiply by the cube root of 49 over the cube root of 49. And again, this is the hardest of this type of example we're going to find, because I'm not going to have you rationalize the denominator with cube roots, anything higher than cube roots for that matter. But in this case, the cube root of 49 and the cube root of 7 ends up being the cube root of 343, which in this case is perfect because 343 is going to end up being 7. But if you look at the top, 2 cube roots of 49, that's in simplest form. So we can simply go to the answer saying 2 cube roots of 49 over 7 is our final answer. So this is exactly what we want. This, then we can draw a little arrow all the way up here and say this is no good. No good. So right, it's partially what we want, but it's not exactly the simplest form. Okay, let's look at one more example from the second section, dividing like radicals. So if we look here, we can look at an example. We could say the square root of 14 plus 3 square root of 14 plus 4 square root of 14. In other words, You treat the radical as a variable. Thus, when you add and subtract the number of each radicals, in example one, in example, it's the 1 and it's the number 3. So in other words, there's an understood 1 right here. To combine like terms, close parentheses. So in this case, we're adding this quote-unquote coefficient of each of the radicals. 1 and 3 end up being 4, which ends up being some type of value when you plug it in the calculator. So in the similar scenario, let's look at something that's a little more complicated. So this is very general case. Let's look at something more, in depth. So the cube root 81 looks nice in appearance. Oh, it's going to be 3, but that's the 4th root of 81 is 3. So if we know that's not the case, we have to search for something. Well, I'm guessing that this ends up being something where the cube root of something with a 3 is involved is going to be something put in simplest form. In this case, the cube root of 27, you can see this broke down into these two values, which we know we're not to do that. We've dealt with this before. Cube root of 27, some action this checkpoint quiz. We know that that's ending up going to be 3. So we end up getting that. I don't want to use the word coefficient. That's kind of what it feels like because we treat this component as a variable. So the cube roots of 3 minus 3, the cube root of 3. In that case, there's an understood 1 here. So if we just subtract the 2, it's very simple. It's 2 cube roots of 7. So in reality, this is not a very difficult topic when it comes to radicals, or these types of combining and like radicals with adding and subtracting. But nonetheless, it can get tricky if you have values like this. Say this is something like 85. Well, you have to be able to identify that no cube root, not perfect square, perfect cube goes into 81 as a factor of 81. So you have to identify or 85, I'm sorry, those different situations, which will do with ones that usually come up to this. But this, again, is our final answer for the example. Again, apologize, another lengthy one. Trying to cut these down, do the best that I can. The other part of part B, examples 3 and 4, we'll look at in class tomorrow. Best of luck with this, review it, and then the quiz will be taken after we look at 3 and 4. Okay, thank you. We'll see you in the next one.